Hey, what's up, everybody? We are going to talk about our last type of conic section today, which is the hyperbola. And this is not the thing that your English teacher tells you not to make when you're describing the shortcomings of... I should probably not make these videos political, huh? Anyway, you think of who has the greatest shortcomings, and you know what I mean. This is not an exaggeration. This is a type of function. So, actually, they're not always functions, now I think about it. Anyway, I digress. Actually, they're never functions. You know what? I should probably use my vocabulary a little bit more precisely. Either way, we're going to learn about things called hyperbolas today. You are going to learn how to find the center, and this is in quotes because that's a kind of funny word to say for the shape of the thing we're describing, but I get what they mean, and you'll probably get what they mean when I show it to you, but you know. We're going to find the center of the hyperbolas, and then the length of the transverse and conjugate axes. These are just fancy words for like the up-down axis and the left-right axis, and they switch. They're more described by the orientation of the hyperbola than the up-down left-rightness of it. But don't worry, I've got some slides that will demonstrate to you what that means. Cool? All right, now that you've learned a bunch of words that can impress your parents when they ask you what you're learning, let's go learn about hyperbolas a little bit, shall we? So, as always, we're going to start by looking at some cones. So, we are on the last conic section, even though there's a secret fifth conic section that I'll tell you about someday, maybe. We're on the last true conic section that looks interesting and not boring. So this is a hyperbola. Right here, you can see that little shape and that little shape. This is what we get when we take a plane and let it intersect our cones on both sides. Here, the circle is perfectly flat, so it's never going to touch up here. It's only going to hit one cone. Ellipse is tilted a little bit, but like this thing's never going to come up here and hit that thing, so don't worry about that. The parabola is specially oriented to be parallel so that it doesn't hit. So the hyperbola is what happens when we let our plane intersect our cones vertically on the top and the bottom. So anytime it's going to hit both cones, you're pretty much going to get a hyperbola. All right, so let's investigate these equations. I don't know why I drew that out. That was kind of weird. So we, just like before, we have some stuff squared, some more stuff squared. We have an h that moves stuff sideways, a k that moves stuff up and down, and then we have an a and a b just like we did in ellipses. The only difference between the equation of an ellipse and a hyperbola is this sign right here. This is now a minus sign instead of a plus sign. So that completely changes the way the graph looks, obviously. Ellipses are ovals, hyperbolas are weird things. They actually kind of look like parabolas, but if you took a parabola and then kind of graphed it and put it on top of a hyperbola, you'd see that they're not quite the same thing. But they look similar if you just look at a little chunk of it. So, all right. Just like ellipses, there are two different equations. There is this one, where the a term is under the x's, and the b term is under the y's. And then there's the obvious other version, where the a is under the y's, and the b is under the x's. What is far more important, though, is which term here is negative. You want to think about this as the y term is now negative, or the x term is now negative. Whichever one this negative is on is going to completely change the way our graphs look. So we just need to be conscientious of that and make sure we're looking for it so we make sure that our hyperbola is oriented in the correct direction. So let's go talk about what that negative and what changing it from the y1 to the x1 will actually do to our graph. All right. This is probably the more standard one that people generally think of when they think of a hyperbola. If you filled in your h, k, a, and b, and you just put numbers in there, I'm going to graph what's considered maybe the parent function, your hyperbola will look like this. All right. So if the x term is positive, you're going to have the hyperbola, or the graph part of it, it's going to be going in the positive x direction and the positive or the negative x direction. If we switch which term this negative is on, so I put it on the x terms instead of the y's, and I make the y's positive, what that does is it takes our hyperbola and it makes it go up and down as opposed to left and right. And that's the only difference. So whichever term is positive, that's the axis that the hyperbola goes along. So if y is positive, it goes along the y-axis. If x is positive, it goes along the x-axis. Now you're going to ask me, well, what are all the other numbers do? So h and k do the same thing h and k have done since you were in like your kindergarten algebra 1 class. They shift your graph left and right. Now a and b have a similar property to what they did in ellipses. They tell us how big our hyperbola is going to be in the x and the y direction. But if you allow me to go back to those graphs that we were just looking at, how big doesn't really make a whole lot of sense for these, because we have arrows, which imply that this graph keeps going forever in both directions. So if something goes forever in a direction, it's kind of hard to quantify how big it is. But what these A and B's will do is they'll tell us the difference between a hyperbola that looks like this and maybe a hyperbola that looks like that. They adjust how wide your hyperbola is or how narrow and skinny the hyperbola is. So let's go talk about a couple of vocabulary words just so we kind of nail down what they mean, and then I will show you pictures of them to help you understand what I'm saying, because these words are not words that you're going to see in everyday life. So in the objective for the lesson, we talked about a transverse and a conjugate axis. So what a transverse and conjugate axis are is they are going to affect the asymptotes that our hyperbolas follow. So the transverse axis is the axis that passes through the middle of the hyperbola, and the length of the transverse axis is given by 2a. I want to point out that the positive term is always the one with the a underneath it. So if our hyperbola is oriented in the horizontal direction, meaning the x term is positive, that means our transverse axis is in the x direction. Our transverse axis is this. It doesn't necessarily go all the way through. What might be a better way to describe this is this A is telling us the distance between these two vertices. So let's say this A equals 3. What that means is that from the middle of this to one of the vertices, that's 3, and from the middle to the other vertex, that's 3, for a total of 6. So similar to how our ellipse, it told us the distance from the center of the ellipse to the furthest edge. This is telling us the distance from the center, halfway between the two hyperbolas, to the vertex, or the nearest point on the two hyperbolas. All right. Now for B, this is telling us what's called our conjugate axis. And this is just perpendicular to the transverse axis. It is an invisible line perpendicular right through the middle of our two hyperbolas. And you're going to say, what does this distance even mean? So what these two axes do is they create a rectangle. So let's say, all right, if that's 3, this is maybe, we'll say 5, give or take. What we can do and this is not on the test. Not on test. I'm telling you this because I have some vague responsibility to every mathematician that came before me to pass along this knowledge so that you're adequately prepared for a college scenario. And maybe someday you actually do go into rocket science and you change your mind about math. This will come up. So what these two axes do is they create a rectangle. And then if you draw a diagonal from this corner to this corner and this corner to this corner, well, that was terrible. Let's try that one more time. These two diagonal lines are asymptotes where your hyperbola will gradually approach them. So these red ones that I have drawn are not great. Our hyperbola would actually look a lot more like that. So it's going to get very, very close to these diagonal lines made by this invisible rectangle formed by the transverse axis and the conjugate axis. All right, so same thing applies here to a vertical parabola. We could have a transverse axis, and because the A is underneath the Y, our transverse axis would be vertical this time, and our converse, or I apologize, not our converse, our conjugate axis would be horizontal. It would form a rectangle like this, make some asymptotes, and then our hyperbola would look like that. All right, so A and B are just determining the size of this rectangle, and that places the asymptotes so we know where the hyperbola is kind of trapped in. All right, so now that you're thoroughly discouraged, let's go and look at some easy examples to build you guys back up and make you feel like maybe you kind of got this. All right, example number 1. So we want to find the center, the transverse axis, and the conjugate axis. I might be slightly mislabeling these. You've got to forgive me. I'm a mathematician, not a vocabulatician. I'm gonna humble brag a little bit here. Feynman is on record as saying he is also abysmal with names. I apologize to all the PhDs out there watching this, none of you, but what I mean by these two questions, center, okay, the center is easy. I want to know where is that spot. What I mean by find the transverse and conjugate axes are we want to know what is the value of A and what is the value of B. Okay, that's really what we're asking for. So don't freak out with these big crazy words. On your homework even, they will ask you for A and B. They will not use the fancy math vocabulary just to make it extra clear. So what this question is asking us is where is the center? What is A equal and what is B equal? All right, so the first thing you want to do is find your center. H is, of course, with the X, and it is, of course, the wrong sign because it's inside a math operation. So our H value is -5, and our K value is with the Y, and it is reverse sign as well. So K is +3. Your center is still at HK just like it's going to be for the rest of your life. So the center of this hyperbola is going to be at -5, 3. Now to find A and B, the first thing we need to figure out is A underneath the Y or is it underneath the X? A is always under the positive fraction. The one with the negative sign has B under it. So A is under our Y here and B is under our X. And remember, this is A squared in the equation and B squared in the equation. So to find A and B, we just take square roots of both of these numbers. So A is going to be 2 and B is going to be 6. And again, we don't really want to worry about the square root being ±6 or ±2 because we're asking how wide is something. Generally, we don't care. Negative lengths don't mean anything to us. You can't say I'm -6 feet tall. If you were, that would be abysmal, right? You would never get a date that they'd say, you're too short. You're so short, you're negative shortness. Like, oh my, I can't even imagine the roast that you would have to endure as someone who's negative 6 feet tall. All right, so center is at HK. Make sure you flip the signs. H goes with X, K goes with Y. A is always underneath the positive term. Make sure you take a square root. B is always underneath the negative term. Make sure you take a square root. Let's do one more easy example before I scare the bejeebas out of you. All right, center is at HK. A equals B equals. All right, the positive term here is X. The negative term is Y. So this is B squared. This is, oh, no, it's not. Barton, get your life together. This is A squared. This is B squared. All right, H is -7. K, there's not a number inside this Y, so it's -0. So because there's nothing there, it's 0. There we go. -7, 0 is the center of our hyperbola. A, take the square root, is 9. B, take the square root, is 4. There you go. You're doing it. Look at you. You're a mathematician. You know hyperbolas. All right. Now, of course, our 3 greatest fears in life. Fractions, disappointing our parents, being eaten alive by caterpillars from the feet up. Let's go talk about this one. Maybe our greatest fear isn't fractions. We're going to get some fractions, but maybe our greatest fear is completing the square. Look at that. Mathematically accurate square. Boom. All right. So we need to turn this thing into this form. Right now, it's all foiled out. All the denominators are gotten rid of because our greatest fear is fractions. Completing the square is our second greatest fear. So we need to take this thing from standard form that it's in now and put it back into regular vertex form. Okay? So, like normal, we're going to group our terms together by variable. So let's go ahead and do that. And our constant is already on the other side of the equation for us, like we did in the last video. So we're going to just go ahead, move some of this stuff over, and then we'll complete the square from there. So grouping our y's, we have y squared minus 8y plus blank. And I'm just going to put the plus blank so that we have our space to fill in later. All right, now if I group these x's, actually, let's go ahead. Group the x's. Let's get rid of these parentheses. Maybe I was a little hasty. Whoops, too much. Actually, there we go. Let's get rid of these parentheses. I was a little too gung-ho there. All right, we have negative 4x squared minus 8x. Okay. Sorry, plus blank. Get rid of this thing. Equals 4. All right. Now completing the square here. On the y's, this is pretty straightforward because we don't have any coefficients we have to factor out like we did on the ellipses for the y. So this is going to factor to y and something squared. And this something is just half of whatever the linear term is. So this is going to be y minus 4. And then the number that goes in this blank is whatever this number is squared. So negative 4 squared is positive 16. Because I added 16 on the left side, I need to add 16 on this side. All right. I might be getting a little ahead of myself here, but here on the x's, to complete the square, the first step is we need to get rid of this coefficient because you just can't complete the square when a isn't 1. We also need to make sure, because this is negative, that's a huge hint to us that x, where'd I go? Here we go. X is going to be the negative term. Whichever one has the negative coefficient, that's the thing that's going to be over the b and be the conjugate axis. So we know because this coefficient is negative, this is going to be the negative bit. So let's factor out our GCF. Let's take out a negative 4. Negative 4. So this could be x squared minus, plus, right? Negative 8 divided by negative 4 is positive 2x plus blank equals, and we'll simplify this. I add the 16, so let's add these as 20. All right. Now we have to complete the square here. So I'm going to just bring down this piece of the y square I've already completed so I don't forget it. Over here, bring down our minus 4. Now we want to complete the square here. This is going to be x and something squared. This something is half of your linear term. Divide by 2. So this is going to be plus 1. Now to fill this in, it's this number squared. So this is going to be 1 squared is 1. Now putting the 1 here, we're not just adding 1 because it's being multiplied to the negative 4. So you need to multiply the coefficient to whatever you're adding, and then that's what you're really adding to both sides. So negative 4 times 1 is negative 1, or I apologize, negative 4. So because we're subtracting 4 total on this side, we need to subtract 4 over here. So this side is going to turn into 16. All right, this is looking a lot more hyperbola-y. Now we just need to turn this into a 1. And the way we do that is we divide by whatever that number is. So we divide by 16. Whatever you do on one side of your equation, you must do to the entire other side of the equation. So divide by 16, divide by 16. Let's clean this up a little bit so it looks nice for the people at home. This is y minus 4 squared over 16. You cannot reduce this 4 and this 16 because this 4 is inside another math operation. So it's kind of like blocked or shielded from the division. Don't reduce those. That's a big no-no. All right. Negative 4, this is outside the math operation, so it's susceptible to the reducing. So negative 4 over 16 is negative 1/4. Then we bring down our x plus 1 squared, and then 16 over 16 is, of course, 1. Now this, we can just read off our center and our a and b. So the center is going to be at, here's our h because it's with the x, so h equals negative 1, flip the sign. K equals 4 because we flipped the sign. So our center is at hk, so negative 1, 4. A is always under the positive term, and remember we have to take a square root because this is a squared. So take a square root, a is 4. B is always under the negative term, so this is b squared, take a square root, and b is 2. There we go. Hopefully that wasn't quite as scary as the ellipses, especially now that you've done the completing the square for circles, ellipses, and hyperbolas. So we should be getting a little bit better at it. If you're still terrified, I don't have a meme for you, unfortunately. Look, no angry kid on this one. Sorry. If you're still scared, though, make sure you hop in the WebEx, say, Mr. Barton, I don't want anyone else to know, but your lesson was terrifying. Can you please throw some other kid under the bus and say that they asked you for help, and then do a couple examples for me so that I can learn from them? Absolutely, my dear, dear students. I would love to throw another kid under the bus for you.